good morning, Willow. Willow and I have been studying this schematic right here this morning, and we're getting ready for our next class today. And Willow is pointing out to me, since there's not a whole lot going on the front end on this radio, we may take on two sections. Willow says it'd be better maybe to take on two sections. So what we might do is we might take on the mixer oscillator section, and we might take on the front end section today. So I'm going to take Willow's advice today, because she's pretty smart at what she's doing. And she's saying, Dad, you need to have a bigger class today to hang and get two of those things out of the way today. So that's what we're going to do. I'm taking her advice because she knows what she's doing. Hello, this is John from Indiana. Welcome to the Radio Hound Tube Radio Restorations YouTube channel. Today our video is going to be all about the front end of the radio. I have made the decision that we're going to go ahead and do two sections today. I think we can do that in the amount of time that we have for this video. So we got a lot of action-packed stuff coming up. There's going to be a little more meat and potatoes coming up. It's going to start coming together to you as we move across this radio. And then eventually, when we get done with all this preliminary stuff, we're going to get into the actual radio. This is the radio we're going to be doing. So, but I just got to get through a lot of this. I want you to enjoy yourself today, and I'm going to be showing you several little things. So thank you for your time today. So today's video, we're going to try to go over two sections. The front end's not going to take a whole long time. So I'm going to go ahead and add in the mixer oscillator section. Now when I'm saying the word mixer, it's also called the converter. But this will be the converter tube, but it's also called the mixer tube, and you'll understand why here in a few. And then this is your oscillator section down here. So we're going to start on the front end side, inside this pink line. Now, the last time I drew this, I just drew swatches across here, kind of break those sections down. But this is more realistic, the lines that I drew here today. So what we're going to do is we're going to start right here at the front end of the radio when you're first coming in. And the first thing you run into, and I'm going to try to blow this up a little bit better, is you run into the antenna section, because you have to have an antenna to make one of these old radios work. I'm going to move my lighting up here a little bit. All right. Should have had all that ready, and I didn't. Okay. But this is your front end of the radio, and you got an A, a Z, and a G, okay? And how they have this set up is your A and your Z are hooked together. But technically, when you're running just a single wire antenna, these radios operate off of a long wire antenna. Usually, like 100, 125 feet long. In the old days, they'd run them out across to a tree or across your house or something like that. But you would connect that wire onto this A block. Well, that A block is sitting right here, okay? And anyway, that's where you would connect that long wire to. And let me back up on that. That's right here on the back of the radio. But you have your A and your Z and your G. Well, you notice like on the picture, they have a little metal plate that goes between A and Z. But if you're not using, and I'll explain what the Z is about here in just a second. But if you're not using the Z, then you just ground it out to G. If you're just going to use just a long wire, then you just ground out to D. What's the Z for? Okay, the Z is when you have a doublet antenna. In the old days, they liked the doublet antennas because it would help them have better reception on the other bands and get into better reception basically in these other bands that you have. Well, they had it where you could hook a doublet antenna. A doublet antenna, if you're ain't familiar with any kind of FM antennas, they have what they call a dipole antenna. It's similar to that. It's a center tapped antenna. I've got a dipole in my shop. It sits right here, but I'll try to get it in frame. That dipole antenna has two wires that run up, and then they run along either side, and they run out so far to the ends out here. but it's centered, and so those two wires would come down and they would hook on to these two right here, and that would connect your one side. The doublet antenna would connect to those two right there, and that's why they got that. But the bottom line is, for me, I don't use a doublet antenna. I use a regular long wire antenna. So you could take this and you connect it over between the Z and the G, and just leave the A exposed by itself. So you hook your long wire here. So then there's your wire coming in, okay? And that wire comes in right here, and there's nothing in the way. There's no capacitors or no resistors. So the first thing it comes to is this big box right here. Well, what is that? It says it's a wave magnet. So we're going to go out to the garage, and I'm going to show you what the wave magnet. I kind of showed you on the intro when we first bought the radio, but we'll go back over there just real quick and kind of give you an idea of what happens there after that long wire antenna. Because I personally will never use that Z, so I always just hook the two together and have the A here and the Z and the G be my ground. Now, if you want to, a lot of these old radios, you don't really have to hook a ground. What they do is they put a big old rod in the ground and have a grounding wire actually going to ground. And if you're going to leave these things plugged in, then that'd be a good idea to have that ground hooked up to that. But I always tell everybody to unplug your radios when they're not in use, because you can have lightning come in. And you know, in the old days they had lightning arresters on the house and stuff like that. Well, now we don't have that stuff, so you're going to end up burning something up. But if you're going to leave it plugged in, which I recommend not to, make sure you collect or plug in, and you have about a 4-foot grounding rod in the ground. And that's what this little wire is I've got right here. I've got a grounding rod that goes outside right outside my window here, and it connects down to ground. All right, so we're gonna stop the video here just for a second, go out to the garage and film. I'll show you that wave magnet. Okay, here is your wave magnet, and a lot of the Zenith radios had these, and it fits right here in the back side of the radio, and it's underneath the bottom here right beside the speaker. And when that antenna, the first place it goes to, it goes into this wave magnet. Well, the wave magnet is just a little bit of fine tuning. You can rotate this and point it in the angle of where your signal's coming from, and you can just tune it in a little bit louder. You got the long wire connected, but you can get it in better by just rotating this magnet a little bit. That's called a wave magnet. So that's it for that. Back to the video. I just showed you where the wave magnet was and what it looks like out there on the radio. But that's what these coil of wires are. Now you notice if you have the doublet hooked up, it's going to go through that wave magnet too. So either one of these, that's what these 4 connections are. These 2 are for the main antenna wire, and the other 2 are when you have the doublet hooked up. But all of those go through that wave magnet. It's just a little bit of fine tuning, okay? Then the next thing it does is it comes off of that antenna, and it goes through a coil right here, and this is your antenna coil. Now you have switching that goes on in this antenna coil. I'm going to zoom this back out so I'm not shaking so much. But you can fine tune your coil, and that's what this switch is doing. You can switch between bands, and you can tune this antenna coil, and this is all done when you actually do your alignment process. This is at the end of when you get your radio all recapped and complete. You'll come back and you'll tune this, and you also have what you see right here. It says C1, and if you look down here at C1, it's a 3-gang variable tuning capacitor. Okay, so that C1 is this tuning capacitor right here, okay? And C1, this is just one part of C1 that you're seeing right here. That's C1, and usually, most of the time, it's this front one here, and that's your antenna tuning, and they'll have a little, this one does not. This radio does not have it. But see that little screw on the second one? And on this one, this might be the RF tuning capacitor, I'm not sure. But either way, if it has a little screw here, then you can fine tune that tuning capacitor. But this is a capacitor where you will dial in on your radio station, basically, for that. But you can also fine tune on that. Okay, so then after it comes out of this switching system, then it has to go somewhere. So it's coming, and here how you can always tell on these tubes. On most of the old schematics on the tubes, the line that comes in from the left side of the tube is your entry point to where your signal's coming in. See all these other lines, there's no line coming in from the left. They're all coming in here, or they're interconnected, but there's always one line that comes in. Just like, for example, on this tube, on this next tube, you see one line coming in from the left. All the rest are down underneath or on the right. See this tube right here? It only has one line coming in from the left, and that's your grid. Most of the time, it's your control grid. But it'll come in, and this is where your radio signal, how you can track your radio signal. This is your RF coming in here. Well, that RF, that's your radio frequency that you've dialed in right here. Your radio frequency is going to be coming in on this tube. What does this tube do? This tube will amplify your antenna signal, because sometimes the antenna signal is not super strong, and then you'll have a tube here that's what they're designed for, is to amplify that signal, and that'll give you a better signal coming out. And then that signal gets bumped down here, and then it goes into an RF coil, okay? And this is one of these sections over here. I don't know which one, but you'll have one that's an antenna, one that's RF, and usually almost always the oscillator's on the back side. So you have three sections: antenna, RF, and oscillator, or it could be RF, antenna, oscillator. I don't know which one these two are yet, but the bottom line is those three C1s will be on each one. Like right here's the C1 for the oscillator. This is the oscillator section. There's a C1 for that, and then you should have a C1 somewhere down here too, and right there. So you have that C1 on the RF section. So you can, when we actually look at this radio, we'll follow our wires and we'll figure out which one of these is antenna and which one's RF. But bottom line is, what you're doing here is you're trying to fine tune in this front end. You're trying to fine tune your signal. So whatever, say you picked ESPN 960 in our area, okay, if you got ESPN 960 coming in, you're dealing with that radio frequency up to this point, okay? So what you're doing is you're trying to fine tune it. It gives you several places to fine tune it. You can fine tune it here at the antenna coil. You can build up the volume and the amplification on it right here with this RF tube. And a lot of radios don't have that RF tube. A lot of them just skip that part. A lot of them don't have a lot of anything, and it comes right out of that switching and goes straight into the mixer tube. But they're here. This is a nice radio, Zenith, and they're doing their boost here, they're doing their boost here, and then they're doing their volume control amplification here. Then they're sending it down here to this thing, and where they can fine tune and really get a good signal coming out of there. Okay, so the bottom line is, when you get all done with all this, and these three panels of switches all help all this happen. Okay, so while you're turning, remember these wafers, the wafers that you see here are all on the same switching thing. They're right here. I don't know which three those are yet, but like there's two sides to that one, there's two sides to that one, and two sides to that one. So there's 6 total there, and 3 of them are involved in this front end. All right, but whatever comes out of that third one, and we'll figure out where that's at when we're done, is what gets kicked out to the converter tube, the mixer oscillator tube. Okay, and this is the part that is where the whole purpose of this front end is to give us a real good clear RF signal, whatever, say it's 960 or whatever. You got your signal coming in right there. Okay, let me see if I can zoom in on that too. Okay, we're coming out of that thing jumped on me, out of that switching system, and we're going up here to the grid. This is a grid on the 6A8 converter mixer tube. okay? Now, this mixer tube has a lot of functions, so I'm starting into the next section now, okay? So we got a good clean signal and an amplified signal coming into that tube. Now, the experts are going to say, oh, you missed a lot of stuff over here. Well, I'm not after theory. I'm after basic concept. Basic concept for beginners. Just needs to know when I plug in my wire to the antenna, I'm fine-tuning that signal that I dialed in on my tuning capacitor. I dialed in my favorite radio station. Well, now I'm just fine-tuning that and giving me a good, clean radio station right there on that signal, okay? So now we've got it inside this converter tube, mixer tube. I'm going to call it the mixer tube because the converter is an old term for it. All right. So now it's the mixer tube, and it's got some work to do. Okay. This mixer tube does a lot of things. Okay. First thing it does is it provides an oscillation. Okay. This creates an oscillation, and basically these wires right here are creating basically, okay, you got an AC signal coming here with this sound on the RF side. RF has an AC signal because anytime you hear audio, you got an AC signal. You wouldn't hear the audio if you didn't have an AC signal. You have that plus and minus just like that over that zero, and if you have that plus and minus, not on an auto, it's going to look different than that, but the bottom line is you got movement on that wire. It's not DC, it's AC, and because it's AC, you have to match that with the oscillation part because these two are going to combine in this tube. Okay, so you have these wires down here that goes down to this section, and this section has different coils, and you see these letters right here. You got a K, an N, and an F. Well, on the radio itself, I'll show you where that's at. I think, I'm guessing where it's at on this one because I have not seen this radio before. It might be on the front. I got to turn this around. Hold on just a minute. Yeah, it is. I see it on the front. See these little holes right here? Well, inside these holes, there are, let me see if I can get up in there, these trimmers. And these trimmers are these letters right here. And let me get it focused back in here. Okay, there are the letters, the K, the N, and the F. Those are your different bands that you have on the radio, and that's what this switching is over here for. When you switch to, like you have the shortwave band and the police band and the other bands. I think there's 3 bands on this radio. But basically, this coil right here is going up against either one of these bands, whichever one you got dialed in. It's the other side of that matchup to that. And because, and I'm not going to go into the theory of how this happens, I'm just going to tell you it happens. You get plus and minus going on here. You'll have positive voltage and then negative voltage, positive voltage, negative voltage. What did you just create? You created that AC wave band that's going to match up with the AC wave band coming in from your audio, bottom line. So this oscillator is creating that by sending voltages out that it's receiving in. These voltages are coming in from this side over here and going into this switching system, and it's shooting voltages in there, and then that'll come up here on the grid, and it'll give you a positive and a negative. And when the grid goes positive, it does certain things. When the grid goes negative, remember, when the grid goes negative, it's gonna send more electrons up. When it goes positive, it's gonna send less. So you're creating an AC signal. Well, what that does, it makes it to where you can combine, and this mixer, and this is where, that's the oscillator portion, what it's doing down there, giving it that signal. And you got your RF coming on a signal. Well, it combines those, okay? And when you add those two things, the RF signal coming in and the oscillator signal coming in from this end, that converts into here. And I get tickled. These guys are talking about, if you go watch some of these videos on how the oscillator mixer section works, I get tickled because they say, here's something that comes out to a lot of them. It says 1 + 1 equals 4, okay? And what that means is this converter is going to put out 4 different frequencies. Okay, the first one is going to do, let's just say you had, for the sake of math, you had 1K whatever frequency coming in here. Instead of the 960, we'll just round it up to 1K, okay? And then on here, because the the tuning capacitor itself is ganged. Like when you turn one, you're going to turn the other one. They're set up to where they're so far apart from each other. So if I have here one, and let's just say coming in on this oscillator section, I have 1.5K. Okay, all right. So if I tune this to 2, then it's going to be 2.5K because it'll tune right along with whatever you're tuning here. So it's going to move the oscillator one too. So it's going to keep that same distance apart between what you have on the RF side and the oscillator side. And there's a reason for that, because that's one of the frequencies you're going to get, is you're going to get the sum of the two. So that, because you're going to have the 1K plus the 1.5K. So you're going to have, 2.5K. And then you're going to have the signal of each. You're going to have the 1K, okay? And then you're going to have the 1.5K. And then you're going to have the difference, which is 0.5K. So you're going to have 0.5K. So you're going to have 4 different signals coming out of there, okay? And there's actually a few other things it does, but the 4 I want you to remember. Okay, so what we have to do is we're going to have 4 signals, and I wrote that horribly, but basically you're going to have the sum of the 2 numbers between the whatever frequency you have here and the frequency you have here. It's going to have that sum, and then you're going to have the difference between the 2, which is that, and then you're going to have the individual frequencies, the frequency for the RF and the frequency for the oscillator. All those are going to be right there, okay? But what our next section, and then we're going to learn on our next section, will be the IF section, and that IF section will determine what happens in the radio. On the next one, I'll spend a little bit of time, but I drew a line there. The IF section goes right between here and here. That's IF, between there and there. And I will give you just a little bit of a tidbit and some of you know this, but this is for people who don't. These 2 little coils, there's a coil here and a coil facing it, that's all in the same box. And then you see the little dotted line. Dotted line means it's inside of something, okay? And then you got another little coil and another coil across from it, okay? But these are tuned at the lower part, the difference between the 2, all right? So if that's tuned at the difference between the 2, then, and it won't be 5, it won't be like 1.5, it's going to be whatever that difference is going to be this difference right here. Always somewhere in the middle of your schematic, you're going to have your IF frequency. All right, and that frequency will be that difference, the way these two, each of these are locked on there, that's going to be that difference. So this one's locked on at 455. So that means this right here is going to be tuned, and I'll show you how to do that when we do this next section. But it's going to be tuned to 455 in this radio, okay? So what we're going to be doing is bringing in these 4 signals right here, and then we're going to tune it to the low one right here, the difference on that, and that difference is what we're going to run through the radio until we get out here. All right, so that difference will make it a lot easier for us to work in our signal. So basically you think, okay, well then if that's true, what happened to my RF signal? Because all I'm doing is taking a portion of this IF signal and moving it over here, but it's nothing like that, and I'll explain how that works on the next video. The bottom line, I want you to, the main takeaway on this is over here, you're tuning that RF signal, the radio frequency signal, okay? And this is actually your station that you're tuning in, and you're trying to get a good radio frequency coming into this mixer. All right, that's an AC signal. All right, then you're creating with this tube, we're making this a oscillator signal that is a AC signal that is creating that oscillation. And because if you didn't have that, it couldn't mix anything, because it'd be 2 different things. It'd be apples and oranges, because you're not oscillating. So if you're not oscillating, you just got like a DC line. Well, DC and AC, they're not going to mix, so you can't mix anything unless you have the 2 matching. And I know there's a lot more theory on how that works and why it works and everything. I'm not getting into that. The bottom line is you got to oscillate. If you're not if this portion of your radio is not working, you're not going to get past this point right here. you have to make sure that you are oscillating. And I'll show you right before we start the next section. I'll show you how to kind of test that, so you know that your oscillator section is working, because it does make it a pain in the butt if you can't figure out, you know, why it's not working. But the bottom line, there's one more thing that this tube does, and it amplifies. Just like any other tube, it amplifies. So not only do we amplify here, but we're amplifying more right here. So we're getting a good amplified signal that's mixed, that has these 4 signals on it coming out. And one more thing that I didn't say before, I probably should have, is when you bring something into a tube, it's usually going to come in on a grid somewhere. Remember the line that comes in on the left side of the tube. All these tubes have lines coming in on the left side of them. You can look all the way through here, and all of them have something coming in on the left side of them. Now, if a tube's angled a different direction, it's going to be on this side, you know what I mean? But it's always going to come in, because your flow on a schematic moves from left to right on most schematics. So the bottom line is, it's going to come in the grid, it's going to go out on the plate or the anode. And the plate is always your exit place for your audio. Your audio will come in here, and you'll come out here. The audio will come in here, it'll go out here. The audio will come in right, let's see, on this one, right here, and it'll go out here. So you kind of get the gist of that. So takeaway points. We're tuning our radio frequency here, and then we're sending it out. When we send it out to the mixer converter, and then we're sending it down here to the oscillator, creating an oscillation. Then we're mixing it inside this tube, amplifying it, and sending it out to this IF can, what we call an IF can, intermediate frequency can. And that can does something. In our next video, we'll talk about what it does. Like I say, I know there's so much more here, and if you want to watch any deeper on this, go find one of the experts and watch their videos. But right now, I'm just showing you what's basically going to happen when it goes through. I'm probably using the wrong terms. Matter of fact, I know I am on some of this stuff, but I want to say it to where you understand what's happening here. What's happening here is we're taking a signal and we're mixing it here with the oscillated signal, and then we're creating a bunch of signals, and we're picking one of them signals, and all this other stuff's going to carry over with it. But we'll show you the next parts of that. Okay. I think I covered everything I wanted to cover today. I hope that you understand just the basics of what I just said. Now you see I skipped down here. These are some coils where you can do some switching. I'm not going to get into that part right now, but these are the basic movement through the radio. Come in through the antenna, go in the oscillator section, and now we're getting ready to move out to the IF section with these signals coming out of this mixer converter that are amplified. All right. If you have any questions, please hit me up on the buttons, and I will try to answer them. In case I missed something, I would love to be able to make you feel comfortable. And like I say, we're going to get through this radio like we're doing here with just a one class on each thing. But then we're going to go back through with our actual radio, and we're gonna be dealing with our radio, so we're going to follow it. Now, I will say this: I started the power supply and work my power supply first, and then I work from this end that way. So a lot of people start over here and work that way. I always work from the output where it comes out the speaker and work back. But you can do whatever you want. I just like working that way because a lot of this stuff you don't really have to check as deep. When you have broken stuff and stuff burn up and blowed up, it's usually over in here. So that's why I start here and I work my way back. Over here, unless something stupid happened, you know, the biggest problem you're going to have over here is this oscillator section not working, because these coils have to make those two different voltages. They're shooting voltage back and forth between these coils, and it has to work right to oscillate. So you might have a problem in your oscillator, but even then you hardly ever have that happen too. I haven't had too many oscillators since I've started this, but I have had a few. And but that's why I start out here. And I think that's what you need to do is just relax and don't worry about it. If we miss something, somebody's going to ask a question, and when they ask a question, I'll address it on the videos. And when I address on the videos, we'll all learn this together. Be honest with you, I've spent time in here, and just my studying to get ready for these classes and videos has helped me to brush up on things that I forgot about. But anyway, bottom line, we're going to have fun with this. Next time I do a video, it's going to be on this IF section, intermediate frequency section. All right, thanks for watching today. I hope you enjoyed today's video. We went over the mixer section and the oscillator section and the front end. We went ahead and knocked out 2 sections, the front end and the mixer oscillator. So I hope that you understood everything that we talked about. If you have any questions, light it up and let me know. I'll do my best to read your questions, and I might have to, I don't know if I can answer, I don't know how many questions I'm going to get, but if I can't, I'll try to answer them on the next videos coming up. So I want you to like and subscribe if you have a chance. Ring that bell. I appreciate it if we can just build this thing up to where we can help a lot of people out there. Thank you very much. Appreciate you watching.